Using Arduino Uno as a DMX controller and receiver to control a strip of WS2812 RGB LEDs as well as a commercial DMX light fixture. I've done a previous DMX controller video that I will link to below, as well as a previous WS2812 RGB LED control video. So those might contain some more insight, but I will also link down below some more DMX information, including the actual protocol as well as the hardware setup. But here's the basic overview. The DMX protocol sends out up to 512 bytes assigned to individual channels over an RS485 communication bus. There will be one transmitter, which is the DMX controller, and then however many light fixtures are going to be controlled, those will be receivers on the bus. So there's a few things we'll be taking for granted for a bench setup like this. For one thing, each side of the actual physical connection bus should be terminated with 120 ohms, as shown in this RS485 network, and I will be using RS485 modules that do have 120 ohm resistors across those data pins, so mine will be terminated. But the other main thing is isolation. I am not using isolated communication or powering, but I don't really need it just on the bench. So there will be links below that show various reasons and methods of providing isolation. For example, instead of just a typical MAX 485 transceiver chip, you can get an isolated transceiver chip that takes care of that, and some of them even have an isolated power supply within it. Or you could just have a normal transceiver like this and use optocouplers to isolate and provide some separate power supply. So there's info on that down below. The main idea for this project, we have an Arduino using a MAX 485 module to transmit DMX data out. Then we have one real light fixture we are plugging in, and we have another Arduino with another MAX 485 receiver, and we're going to control a strip of 60 WS2812B LEDs. I was trying to figure out how to simplify explaining what I have set up, so I decided to put these two schematics side by side. They are both running software from the DMX serial library. One's configured as a master, the one on the left, and one's configured as a slave, the one on the right. So I will defer to the links I'm putting below for more details on how DMX works, but just as a quick review, there's only one master on the DMX bus, and there could be one or multiple slave devices, and they will just listen for whatever channel they are configured at. And you can put several channels on a given fixture. It's not just one address necessarily. So right here I have this WS2812B 60 LED strip, and to start with, I'm just going to control it as if it's all one light. So all 60 lights are always going to be the same color and the same brightness. So I have 4 channels configured in here. One for overall brightness, and the other 3 will let me control red, green, or blue. So I can turn all 60 lights red, or all green, or all blue at various brightnesses. I also have this American DJ microwash RGBW real light fixture that I want to use, and I'm also using 4 channels out of this. It's actually 5 channels, but I'm ignoring the one that controls the white LED in the middle. So over here on the master, what I'm doing is actually taking that American DJ light fixture, I'm plugging it into this XLR3 jack, and then it has a pass-through output, and I will plug that on into here. So it's like having 2 DMX light fixtures controlled by this one master. And with this set up to be identical to the American DJ light, where I have 3 channels to control the whole thing being red, green, or blue, various brightnesses, all I have to do on my master controller is provide a way to control main brightness, which is my first slider pot, or the individual red, green, or blue levels, which is my second slider pot, and I only had 2. So I'm using a switch to go back and forth. Red, green, or blue is what this is going to control. So I can control those features on whatever light, and then I have this other push button to change the channel back and forth between the American DJ light in the middle or this WS2812B light strip at the far end of the chain. Both circuits are otherwise the same. We have an RS-485 interface going to a UART, and an I/O is controlling the data direction. The master sets this RS-485 board to only transmit out, and the software will use the control pin on the slave side, so the RS-485 is only receiving into the UART. So that American DJ light is also going to be a slave device, and it will just be sitting there listening as well. So both of these slaves are going to listen, and when they get data for their configured addresses, they will respond. So I will be running two different test setups with two sets of controller and receiver software. The first set will control as shown here. We have this light fixture that mimics the American DJ light fixture and just controls all of the LED strip lights together. The second project I'm doing has only this one receiver with the 60 light strip, but I'm controlling the lights independently so I can generate a custom pattern on the master, send it over the DMX network, and then generate basically a light show on the LED strip instead of just treating it all as one single light. So let's look at how that software looks. We are using the DMX serial library. So there's some examples over on GitHub, including a NEOPIXEL example. So this uses a somewhat customized WS2812 driver, and down in there, where this comes from, originally some Big Josh code. But the thing about this, the interrupts are disabled and re-enabled as needed, and that makes things more compatible with something like one of these DMX controllers with the UART and all the things going on. I did try the Fast LED as well as the Adafruit NeoPixel libraries, but it was not really responsive, it was flickering, and I think it's got to do with this. So considering they did use this custom RGB LED library and hinting that this is what we need to do, I stuck with this as well. So here's my first project. I called it a manual controller. So on the DMX master side, we include the DMX serial library, but because I have 4 push buttons, I'm also debouncing them with the Bounce 2 library, and the DMX mode pin 2, that's this pin that controls whether we are transmitting as a master or receiving as a slave. Then I have my 2 slider pots. The one controls master brightness, the other controls the individual RG or B color level, whichever we are currently controlling. So we have the brightness here. It's always going to control brightness on whichever light we're controlling. And the channel level will control either red, green, or blue based on which push button was last pressed. And here's the pins for those 4 push buttons. Since I'm controlling 2 light fixtures, the American DJ is configured as channel 5, and my custom LED strip is channel 10. And then some custom variables to keep track of what light we are controlling and what levels we have set. So here, brightness channel 4, that's an offset. Red, green, and blue are offsets 0, 1, and 2 from the main channel we're on, and brightness is offset 4. So what that means is, if we are on light fixture 2, the base channel being 10, red is 10, green is 11, blue is 12, and brightness is channel 14. Standard setup for the switch debouncing, 10 milliseconds debounce, seems to work okay. Then in the setup, we initialize the DMX controller mode using the certain pin that sets it as a transmitter or receiver UART. By default, we're going to control the first light fixture, which is American DJ, and by default, we're going to control channel offset 0, which is red. So we set up our push buttons as inputs with pull-ups. We set up our button debouncers for those push buttons, and to make sure we can actually see something on the light fixtures when we do want to control them, we start out with some amount of brightness, because by default I believe it's off. So sometimes it catches you by surprise, how come I'm not seeing anything? So by default I always turn on some level of brightness. Then in the main loop, I read in the 2 slider pots, and because the DMX values at least on the American DJ light, they don't start at 0, they start at 1 and go to 255. So I decided to just do that for both of my light fixtures here. The analog input is going to go from 0 to 1023, so I'm mapping over the brightness and the RGB channel control to a value from 1 to 255. So now I know what the brightness will be, and I know what the individual red, green, or blue color level is going to be. So now I read in the push buttons and see how I should be assigning these. So let's see what happens in the read button routine in order to understand what we're doing here when we write out to the DMX data. We are reading 4 different buttons, so we use the debounce routines. Then we're just checking if we've pushed any buttons, which would bring them low. So if we had a falling edge on the red button, our target red, green, or blue channel is going to be offset 0. As we saw up here, red is 0 offset, green is 1, blue is 2. So that's the offset from the main light fixture channel 5 or 10. So if we're controlling the first light fixture, which is channel 5, and if we have detected a button press for red, then we are going to be controlling channel 5. If we detect a button press for green, we're controlling channel 6. If we detect a button press for blue, we're controlling channel 7 on the slider pot that controls the color. And for the other push button, which is toggling back and forth between which light fixture we're controlling, all we're doing is, if we get a button press on that switch, change which one we are targeting. So again, if we detect we pressed the button to change which target fixture we want to control, we switch between the other slave or the American DJ light. If we detected a button press on red, green, or blue, this slider is going to be directly controlling red, green, or blue on that target light. And the brightness pot is always going to control the brightness on whichever is our target light. So now that we read the buttons, we know what light we are targeting, we know whether or not we want the one pot to control the red, green, or blue, go out to whatever the target fixture address is and the offset address for the color we want, and send out whatever the value is we mapped over from the red, green, blue slider pot. Same thing for the master brightness. So then the receiver code that goes into the slave DMX Arduino, some of this will be the same, but we are controlling WS2812 lights. So we include that special library, and we're giving the main address, address 10, and we're using 60 LEDs on the strip. Now we want to set our maximum allowed brightness to be 75 out of 255 to keep the current draw low, because I didn't want to bother with a separate power supply for this. I'm just powering it from Arduino, so this brightness level seemed okay. So we are going to read in from the DMX bus what the master is sending us for red, green, and blue controls on this LED strip. So we need to store the red, green, and blue levels as well as the requested brightness for this light fixture, and the same thing about the address offsets. Red, green, and blue are 0, 1, and 2 offset from the main channel 10. Brightness is offset by 4 from channel 10. We have channel 10, 11, 12, and 14 to control these aspects of the LED strip. In order to control the individual red, green, and blue data for all 60 lights, we have this giant array of 60 times 3 for red, green, blue, or 180 elements in the array. And that's what we map out based on what we receive over the DMX channel, and then we send this array out to the WS2812 library to control the LED strip. So we initialize the DMX UART in probe mode, which is kind of like a manual mode. And because we're not using all 512 DMX channels, we're only receiving up to channel 14. So there's no need to listen to anything higher. So we tell it, once you've gotten this many channels, consider the receive done. Then we run this function from the WS2812 library, and this basically sets up pin 12 as an output for the data pin. In our main loop, all we're really doing is constantly getting DMX data from the serial port and sending it out to the LED strip. If we have received DMX data, go in to the addresses for the red, the green, the blue, and the brightness, and read those into the appropriate variables. So again, red is going to be stored in the red channel offset, which is 0, from the base channel of this light fixture, which is 10. So green is going to be in offset 1 or 11. Blue is going to be in channel 12. Brightness is in channel 14. And the reason I did 14 instead of 13 is I wanted this to be the same as the American DJ light. So the channel before brightness would have been the channel for white, but I'm not using white. So that's why I have the weird addresses. I did set my max brightness to be 75. So the DMX brightness is going to be between 1 and 255, but I wanted to rescale it between 0, which is the actual minimum on the 2812 LEDs, and a max of 75. So I'm just rescaling it. And then the way I'm controlling the brightness, for each of the red, green, and blue levels that I received, I'm scaling those by multiplying them basically by the percentage brightness that we are receiving out of the total brightness available. So let's say the slider pot for the brightness was at halfway. I would have received something around 128 or 127 or whatever, and then I rescaled it halfway between 0 and 75, so it'll actually turn out to be maybe 37 or 38 depending on rounding, so that represents half brightness. So then over here, 38 or so divided by the max of 75 is going to be around 0.5, so I multiply my received red level by 0.5, and that's what my red level is going to end up being. So basically, I requested half brightness, and doing all of this, I scale whatever the red is down by half. Same with the green and blue. So since I'm treating the entire LED strip of 60 lights as one light, I'm going through different loops, one for each dedicated color level, and I'm updating all 60 lights with whatever their red levels, their green levels, and their blue levels are supposed to be. So for red, I start at the very first element in the array and set it to the red level that I received and scaled, and then I increase by 3 to get to the red of the next light up until I've reached 60 lights. For green, I start at element 1 in the array and then continue up by 3, and I end up updating all the green levels and then all the blue levels. So now the array has been updated in software, and we go and update the actual NEOPIXEL LED strip with that LED array for 60 lights. So I send it out in the order of red, green, blue, and it sends it out in the correct sequence to actually update red, green, and blue on the LED strip. And I did notice my LED ring of 16 WS2812Bs has a different order. The red and the green are backwards from my strip of 60. So I would actually have to probably change this to green and this to red to make it work. That's basically the code. Here's the complete DMX setup with the controller transmitter over here, the fixture receiver over here, input control buttons and faders for the controller, a WS2812B 60 LED strip as a light fixture on the receiving side, and in the middle I've inserted another DMX light fixture, American DJ microwash RGBW, and that's so that we can make sure this serial communication is legitimate DMX 512. If I can receive the controls here as well as on our circuit and control red, green, blue, and brightness on both, then the DMX protocol is working. On the DMX controller, I have two input faders. One controls the overall brightness of whatever fixture I'm controlling, and the other controls either red, green, or blue on whichever fixture I'm controlling, and whether it's controlling red, green, or blue is selected by a red, green, or blue push button. So right now I'm controlling the American DJ fixture, and the button is set to control red. So the overall brightness I can bring up or down, or the level of the red color I can bring up or down. But if I push the button for green, now I start controlling green. Red stays the same as it last was, and I've switched the mode to control green. I can go to blue, and now red and green stay the same as they were, and blue comes in, but this is really bright, so I'll bring the brightness down. And I'm not sure how it looks on the camera. It's a really blinding light facing the camera. So let me change the ISO a bit. I still don't know if it's improved, but there's separate pairs of LEDs. There's red side by side, green diagonally in one corner, and blue diagonally in the other corner. So if you shine this at a wall, the colors mix and it just looks like an RGB color, but here we can see the individual lights. So I'll just leave the green on. So I turn the fader while it's controlling blue all the way down. Then I press the red button and red goes all the way down. So we just have green on. So now I'm controlling green. I'll leave it about there. Now I'll push the button to select the other light fixture. So now green is being controlled here, which is hard to see. So I'll turn down the lighting. So on the LED strip now we have green being controlled. So I'll bring the level up, down, for the green color, or the master brightness of the entire strip. So I'll bring in red, and now we have yellow, or green as I fade red up and down, or keeping it yellow, change the master brightness and yellow goes up or down. Add blue, and now we start going white, so I can bring blue in or out, and bring the master brightness of this white up or down. Change back to the first fixture. Now I'm controlling blue, press the red button. I'm controlling red, master brightness. And now looking at the actual animation for the WS2812B 60 LEDs, skipping through because we've already covered the DMX stuff. This is the master controller. So I've got 60 LEDs that I want to send out control data for across the DMX bus. I'm going to need an array to store the red, green, and blue individual values for all 60. So there's 180 array elements. And this is a slightly modified sketch from the LED chaser I did on a previous video for how to use WS2812B. So that will be linked below, but basically I have LED bar that's 3 lights long, and they start out slightly offset from each other, and they both go up and down, back and forth along the strip at different rates, and eventually they overlap, and when they're overlapping they actually combine their colors because they're going to have some blue and some green on. So this controls the position and the direction they're currently moving. So this is the master controller, so we initialize the DMX serial port as a controller, then we draw the 2 color bars, and I'm using a brightness level of 150 out of 255. So all these numbers like plus and minus 3, I basically had to hack this from my original demo because it was done differently, but what it's basically saying is, for one of these 2 color bars, set a certain R, G, or B value to 150 to turn it on somewhat, and then go 3 above and 3 below in the array to get to that same color position, red, green, or blue, of the light above and the light below. So I'm turning on the same color for 3 lights in a row at a level of 150. So I end up with a strip of 3 lights of a certain color, and then a different position in the color array. I turn on 3 lights in a row of a different color. So then I made this little function called send DMX data, which basically goes out and sends all of this RGB data for all 60 LEDs out on the DMX bus on their individual channels. And then I wait 100 milliseconds to give it a sense of animation between where it currently is and the next phase that we draw. So the send DMX data function, all it does is loop through all the channels, all 180 controls for red, green, blue times 60 lights, and send that value out to the DMX bus in the individual channel. So I'm sending out a long DMX string of 180 data points, each representing red, green, or blue for one of 60 lights, discrete control. Then on the receiving side, I get this back into the Arduino and then send it out to the LED strip to control the colors. So then, just like in the original WS2812 video that I did, all we're doing is we just drew the two bars and we sent that color data out on the bus. Now let's turn those bars off because we want to blank them and then send out the new array of data. Then we want to move the bars slightly forward or reverse, so we recalculate where the LEDs are going to be on. We start the loop again, and the position of the first bar, position of the second bar, and the two lights on each side of each bar are going to get green or blue again and send that out, and so on. So we're basically animating the two bars independently at different rates, sliding to one end, turning around, sliding to the other end, and back. And another thing to mention, in this particular project, I don't have multiple lights and I do have a lot of channels. So I'm starting at channel 1, which is the first usable DMX channel. So over on the receiving sketch for this project, my DMX start address likewise is 1. I have 60 LEDs. And the length of my DMX data is going to be 180 because there's red, green, and blue times 60 lights. So the reason I want to track that, there's no sense in receiving all 512 channels of DMX data if we only have 180 that we care about. It helps things run more efficiently. So we initialize the DMX as a receiver in the DMX probe mode, and we notify it that we only care about the first 180 channels. So we configure the LED strip with the WS2812 custom library dedicated to pin 12. And in the loop, we just wait until we do receive a packet of DMX data, and then we just go in to the NEOPIXEL library. We pass on the pointer to the buffer where we are storing this LED data that we receive in the DMX library, and we tell it we have 60 LEDs, so it knows how to go in and get RGB for all 60 LEDs out of the buffer where DMX data was received. So that's basically all we're doing. Every time we get DMX data, update the LEDs with it. So using both of these test programs, we can show how we can do something manual like controlling brightness and color data with slider pots. Or if we want to get into more complicated stuff and control scenes and do animations and control multiple lights, we can see how easy it is to send out hundreds of channels of DMX data and make all of this come to life if we have an application for this. So between projects like this and the reference data that we can access about how to properly implement DMX in hardware, how to safely do isolation if we need, things like that, we can do some fancy things if we have DMX lighting fixtures or other things that we want to try to automate with an Arduino.